Problem 10. And it's an inequality. And it's very nice because it's already in a standard form. And it's already factorized. So you have it's a bunch of multiplied factors on one side and 0 on the other side. So all we have to do is just to decide when is this expression 0 or greater than 0. Okay, so it can't be negative. The first thing, what is the domain? When does this make sense? What can go wrong? Well, we don't want to divide by 5, right? So x plus 5 cannot be 0, x cannot be negative 5. So whatever the solution set is, negative 5 is not in it. So after we figure this out, well, one thing you might do is that just multiply by x plus 5, because that sort of disappears. But in that case, you would need to do two cases. One is that when x plus 5 is negative, then this turns around, the relation turns around. And you also have to check when x plus 5 is positive. So that's one way to do it. But anyway, if you do this systematic analysis of the sign table, by sign table, then that's there as well. So if you ask, oh, what are the critical points? Critical points are when some of the factors, at least one of the factors, change sign. Okay? So we know that negative 5 is a critical point. Negative 4 is also a critical point because x plus 4 changes sign there. And 3 is also a critical point. So what do we have here? Well, okay, let's just do this. So we have negative 5, we have negative 4, and we have 3. And here we have the interval from 3 up to infinity. And here we have from down to negative infinity, from negative 5. Okay, now we have all numbers between negative 5 and negative 4. And here all numbers between negative 4 and 3. And here we have the actual factors. So I have x plus 5, x plus 4, and I have x minus 3 as well. Okay, I know that x plus 5 is 0 here, and it is certainly negative here, but after that it's just positive. Right? So negative 4, or x plus 4 is 0 here, and it's negative, 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 and it's positive, positive, positive. Yeah, it's, I mean, it's clearly you have this pattern. You have negative, negative, then it's 0, then it's positive. Okay, well, these are linear expressions, as we will talk about it later. So this is 0 here, positive there, and whenever it's smaller, then it's just negative. Okay, but what we are interested in this expression, so I need to put this in x plus 4 times x minus 3 divided by x plus 5. Okay, so that's just multiplying the signs. So this is negative. Well, this is actually undefined because we divide by 0, so this is not in the domain as well. This is positive, and well, this is 0. So this is negative, and well, this is 0 as well, and this is positive. Okay, so what are we looking for? We want to look for positive, the positive cases, including 0. So yeah, this is certainly good, and this is good as well. So that I can just read off the solution set here, and that will be this interval. Okay, so we don't include -5, it's not even in the domain, but -4 we include because that's 0. 0 is allowed. And then I take the union. Well, it's like the solution set has two distinct parts, and we go from 3 up to infinity. Okay, and that solves problem 10. And well, I checked the result with GeoGebra, and it turns out that we were actually right. It's negative here, but it's 0 at -4, then it's positive, and it is also positive when its x is bigger than 3. So again, visualizing in a computer algebra system like GeoGebra, it's actually quite useful to check your solution.